Everyone open your books, section 6.4. What is the title of this section? Isosceles triangles. Damon, could you close that door, please? I spelled that wrong. Okay. What we're going to talk about is some properties inside of isosceles triangles. Okay. First of all, we have to remind ourselves what is an isosceles triangle. Anybody? Triangle with two equal sides. Okay. I know I made it a little crooked, but it doesn't really matter. Those two are congruent. That is an isosceles triangle. We have actually talked about this when we talked about medians and things like that, but we didn't really get into it. One of the isosceles triangle theorem, which is very, very handy. Okay? If two sides of a triangle are congruent, then the angles opposite those sides are congruent also. This is something that will come in very handy from this point on. Okay? If two sides of a triangle are congruent, then the angles opposite those sides are congruent also. So what two angles do you think I'm talking about being congruent here? Okay, I have two sides congruent in a triangle. What are the two, angle A and angle C? Okay? Easy enough, huh? The converse of that if two, what do you think I'm going to say now? What's the converse? If two angles of a triangle are congruent, hands have not warmed up yet, then the sides opposite those angles are also congruent. So, as you notice, the things in red are what we started with, right? The things in pencil. So as a result, if these two angles are congruent, which two sides are congruent? AB is congruent to what? Everybody, that makes sense to everybody? So from now on, you see two angles in a triangle congruent, you know the opposite sides are congruent, and vice versa. If the two sides are congruent, then the two angles are congruent. Easy enough, right? The other thing that happens in isosceles triangle. You guys remember me talking about this at all when we talked about medians? BD is an altitude. Median and perpendicular bisector. When you draw an altitude from the vertex of an isosceles triangle, which these are your two bases, and this is the vertex is where the two congruent sides meet, it cuts this in half and it's perpendicular. Okay? So as you can see, there's a lot of little things that could happen in there with isosceles triangle. A lot of, by just saying it's an isosceles triangle, there's a lot of things you already know. You know, these two angles are congruent, these two sides are congruent. If you drew a median, it would also be an altitude and a perpendicular bisector, which would mean it would cut this in half. So as you would think in geometry, what you've hopefully grown accustomed to is there's a lot of different, I don't know, type of questions I could ask you about this, isn't there? So let's get that worksheet out. Okay? I want to remind everyone that notes have to be started on a separate sheet of paper every time, or they will not be accepted this semester. Okay? A separate sheet of paper every section. If you have to rewrite one or two because we just started, no big deal. Okay? Yeah. Very welcome. Okay, let's look at number one. For each triangle, find the values of the variable. Okay. Basically, there's going to be some significant things given to you here. First of all, they didn't say each of these were isosceles triangles, so we've got to figure out if they are. This section is about isosceles triangles, so it's probably a good chance it has something to do with it. Is this an isosceles triangle? So what do I know? These two sides are congruent. What else then? Which angles? These two are congruent. If I knew that angle, could I find those? How can I find that angle? Just erased everything else from your mind and realize that's a straight line, and this is what's left out of 180, right? So what would that be? Anybody? 64? Is that right? So if there's 64 degrees for this one, how much is left for these two? It's 116 degrees left for both of these, is there not? And if they're the same, what's the only way to split up 116 evenly? You divide it by 2. What do you get when you divide it by 2? Okay, it's not so bad, is it? My hand will ever wake up. Questions? We okay to move on? Number 2. Anything significant about what we have here? It's a right angle here. Okay, so I know that's 90 degrees. Let's analyze what else we have. Well, what's this whole section about? Do we have an isosceles triangle? These two are congruent. So this is 6. What's the value of this side? Okay, anything else we know about this isosceles triangle? These two opposite angles are congruent, correct? Is that right? Because those two are the sides congruent, so the opposite angles are congruent. So if this is 90, what's left for both of these to be? 90 left for both of them. So there's only one way to split up 90 evenly. That's to divide it by 2, and what do you get? So that means this angle is what? And this angle is what? My batteries are going dead. Yep, that's what it is. Okay. Let's look at number 3. Trying to trick you now. We got 2 triangles, don't we? It's okay. It's not the end of the world. If this is congruent to this, what do we know about this angle right here? It's congruent to that one, right? And since they said that this one cuts it in half, these are also congruent, correct? All right. So if this is 63, we don't know anything about anything down here, do we? The only thing we know anything about are the congruent things, and the only number we have is this one right here. So where are we probably going to start? By the fact that that makes what? 180, right? So what's left for this to be? Everybody okay there? With that in mind, if these two angles are congruent, these two sides are congruent, making this an isosceles triangle, also, what's left for these two to be added together? 63. So I need to divide that by what? 2. So 31.5 is that one, and 31.5 is that one. So, hold on. So if this is 31.5, what's that? Like she said, meaning they add to 63, leaving what here? 117. I just wanted to work down. So your y is 31.5 and your x is 117. Any questions there? Mm-hmm. No, that's all right. They're more important than there. I'd rather you have a calculator. Nah, that's all right. Maybe after we're done. I'll let you do it after we're done, okay? Right here, number 4. Ah, the evil what? Things that look like an equation, right, Dakota? Just as evil as having to get up in the morning, huh? Okay. What do I know about these two angles? Dakota, what do I know? If these two sides are congruent, what? Dakota? If I know these two sides are congruent, what do I know about these two angles? Help him out. Very good. So, if it looks like an algebra, I probably need to create an equation. So what two things are equal now? I know that the measure of this is equal to the what? What's the measure of this one? What's equal? What's the measure of that? Pretty simple equation to solve, isn't it? Quit getting ahead of me. X is equal to. Questions? Oh, it worked now. Have we got that down yet? Okay. Good? Right here. What do you think? One thing at a time, right? What type of triangle is it? So what do I know about these angles? So right now you know this one is what? 40 degrees. Now, how am I going to find this one though? Well, I could. So how am I going to relate all these? Looks like algebra, probably need to create an equation. There's a couple different ways you could create an equation. You might want to do it in your head, subtract from 180 and start there, but basically, what do I know about the three angles inside of a triangle? So whatever this one is, plus whatever this one is, plus whatever this one is equal to? So tell me my equation. No. All of that equals what? Because doesn't that represent one angle, right? Everyone agree? That represents the other angle, and that represents the third angle. No matter what these three are, we know that those three things added together always have to be what? 180 if it's a triangle. So now you know you've related these in the correct way. Combine your like terms here. You get 4x plus what? Is equal to 180. What am I going to do now? 4x is equal to, divide by 4, x is equal to 22.5, maybe? Is that right? Yeah. Does anybody see when I said there's kind of another way you could do it? I mean, all you have to do is, you know, if this is 40 and this is 40, how much is left for this one to be? So basically 4x plus 10, you know, has to equal what? I mean, if that came up in your mind, great. If it confuses you, forget it. Okay? But if this came up in your mind that 40 plus 40 is 80, so I know there's 100 left for this one, then doesn't 4x plus 10 have to equal 100? Okay. You would have gotten the same answer, wouldn't you? Subtract 10 from both sides, you get 4x is equal 90. Okay? How are they trying to confuse you right here? Where is your isosceles triangle here? It's just right here, isn't it? Wouldn't you agree with me? That's the isosceles triangle, and you got an isosceles triangle right here as well. So if this is 18, what's this one? So what's that? Okay, we got the y taken care of. Now how about this? Obviously, I'm going to have to start over here and work my way over to here, aren't I? Okay, 54, what's left for those two to be? 126, is that right? So divide that by 2, what do I get? So 63, 63. Everybody okay there? Does that add up right? Okay. Now, how am I going to get over to this triangle? What's going to be my key thing to do? Erase everything else and realize that's a what? Erase everything else in your... That's a straight line, right? Did I not tell you you'd use this so many times over and over again? You do, don't you? 63, what's left for this to be? 117. Well, good. I can just look up to the one I did that before. What's that make this one? 31.5. And this one what? Because there's 63 left, right? Good. And since these are congruent, since this is an isosceles triangle, right? Okay there? Do number 7 now. We ready? Sure? Got to be writing everything down about these. Now, on this one, it says in triangle ABC, measure of angle A is equal to the measure of angle C. So this is congruent to what? What does that tell you right now before you go on? That this big triangle is a what? Okay. The measure of angle C is 38. Find the measure of angle A, AD, and AC. And they also gave us this information down here. What is significant about this line? Look at the third thing I gave you in your notes. What did I tell you? The perpendicular the altitude of the vertex, basically, which that's what this is, right? Where the two congruent lines meet is a what? Perpendicular bisector, an altitude, and a median. So perpendicular bisector, what's the key thing there? What do I know this does? Cuts what in half? Yes, but more importantly, what? The bottom, this thing, which is AC. So this is congruent to that. Why is that so helpful? Now I can find what? Because I have a way to relate that to that. What are these two things right here? So what is my equation?
4x minus 2 equals 3x plus 4.
Agreed? What do I need to do now? Add 2. I get 4x is equal to 3x plus what? 6. What's my next step? Subtract 3x, and I get x is equal to what? Now, is that what they asked for? They asked for the measure of angle A, what AD is, and what AC is. Well, the measure of angle A, did we already find that? What is it? AD, that's that part right there. AD is 4 times what? Whatever x is, minus what? What was x?
6.
So what is AD then?
24 minus 2.
24 minus 2 makes it what? So what's A to C? If this is 22, what's this?
22.
What does it make the whole thing? And you're done. Write every bit of that down. It's the last one we're doing.